Now that we have discussed the distribution of the sample mean, we have a way to compare the mean of the sample we collected to the expected mean of all samples coming from the population. So let's do some examples using technology to find probabilities and percentiles and quantiles. So first we have the length of time in hours. It takes an over 40 group of people to play one soccer match. This is normally distributed with a mean of 2 hours and a standard deviation of 0.5 hours. So we know that if we have here the length of time in hours, it takes an over 40 group of people to play one soccer match. So time to play one match, and it is in hours. The mean is 2, and every tick mark is one standard deviation of 0.5, so 2.5, 3, 3.5, and on the left, if it is a normal distribution, we only need to go down by 3 tick marks, and 99.7% of the data will be within 3 standard deviations from the mean. What's the probability an over 40 group will take less than 1.75 hours to play the game? So 1.75 hours is between 1.5 and 2 hours, halfway between, and we are asked to find the probability that it will take less than, so this direction. And again, use your favorite technology to find this answer. I will use Art of Stat, but you can pause the video, use your technology, and then see what the answer might be. I will go into the normal distribution app. I will select find probability. I have a mean of 2 and a standard deviation of 0.5. And I'm going to ask for the probability in the lower tail of 1.75. And that is 0.3085. Mathematically, probability x is less than 1.75 is 0.3085 or 30.85%. Now, once we select a sample and they are asking us to find the probability that the mean time to play the game will be between a certain number of hours, the distribution changes. This is now the distribution of the sample mean, and the distribution of the sample mean is much narrower. So it does have the same mean of 2 hours, so this will be the mean time to play a match, and it is the mean of a sample of 50 people, of 50 teams, and that will be in hours. So now the standard deviation is the standard error, because this is a different distribution. And the standard error is the original standard deviation divided by the square root of n. So 0.5 divided by the square root of 50. So I'm going to go in my calculator to find out how much that is. 0.5 divided by the square root of 50 is this number, 0.07071. And one problem that Art of Stat has is that it doesn't take expressions as the standard deviation. So here, unfortunately, you want to add as many decimal digits as you can. So I will actually add the rest of them too. 06781. And now I have a new distribution. This distribution is much narrower because 3 tick marks to the right goes to 2.2. It doesn't go to 3.5 that our original distribution was. So it only goes, imagine that 3 tick marks to the right takes me to 2.2, which is right here. So the distribution of the mean is actually very narrow. It looks like this. But I have expanded it below so that I can actually be able to write in there. So I'm just going to copy from Art of Stat the numbers. It is 2.07, 2.14, and 2.2. 1, 2, 3. So 2.07, 2.14, and 2.21. And 1, 2, 3 tick marks to the left, and it will be 1.93, 1.86, and 1.79. Let me double check that these are correct values. Yes, they are correct values. All right, and then they are asking us, find the probability that the mean now is between 1.8 and 2.3 hours. The mathematical expression for that is that 1.8 is less than the mean, x bar less than 2.3 hours. And that probability, I'm going to find it in Art of Stat. So I need the probability in an interval. I need x1 to be 1.8, and I need x2 to be 2.3. And the probability, and again it gives me here the expression, is 0.9977. And you see now here that 1.8 is almost all the data values. So 1.8 was here, very close to 1.75. And 2.3 is really farther away from the 3 standard deviations. Very far away to the right. So here we covered almost the whole distribution of possible values of the sample mean. Let's do one more example. In a study reported on October 29, 2012 on the Flurry blog, the mean age of tablet users is 34 years. Suppose the standard deviation is 15 years and 100 tablet users were surveyed. So the sample size is 100, and it is large enough that the distribution of the sample mean, the mean ages, will be normal because n is greater than 30, regardless of the distribution of the underlying population. So regardless of what the distribution of the age of tablet users is, the distribution of the mean from a sample of 100 will be a normal distribution. So the sample mean will approach a normal distribution with a mean of 34 years and a standard deviation of 15 years divided by the square root of 100. The square root of 100 is 10, and that will be 1.5 years. So how do we know the sample size is greater than 30? Find the probability that the mean age is more than 30 years. So we want to draw a normal distribution. This will be the mean age of tablet users in samples of 100, n equals to 100. That will be in years. The mean here will be 334, and the standard deviation will be 1.5. 3 tick marks to the left and 3 tick marks to the right. 35.5, 37, 38.5, and here 32.5, 31, and 29.5. And what's the probability? The mean age is more than 30 years, where 30 years is here, and more is almost the whole distribution. So I'm expecting to find a probability very close to 1. So let's use our favorite technology to find this probability. So I put my standard deviation to be 1.5. I asked Art of Stat to get me the probability in the upper tail, and the value of the variable is 30, and it gave me an answer of probability of x bar being greater than 30. Remember that this is the distribution of the mean. Obviously, any technology you have doesn't know what distribution you are giving it, and that is 0.9962. So the probability that the mean is greater than 30 is 0.9962, which was what I was expecting. Find the 95th percentile of the sample mean age to 1 decimal place. So again, this will be your distribution. Correct tick marks here. Label your axis correctly with numbers and values. Remember, this is the mean age of tablet users for sample size of n equal to 100. It is measured in years, and the 95th percentile will be some value of the variable. We are looking for this x bar equals what? That has the property that 95% of the data of the sample means from samples of size 100 will fall below that value. So if we remember correctly, the mathematical expression is what's the probability x bar less than this question mark value to equal 0.95. And in Art of Stat, we will find this with the Find Percentile Quantile tab. So the mean is 34, the standard deviation is 1.5. We are looking for the lower tail. It is already preset at 95, and it tells us that the value of x is 36.467. And up here in the title, it has written the expression for us. The probability of x, we have to remember that we are now talking about the sample mean, so it is x bar that is our variable, less than 36.467 is 95%. So this value will be x bar equals 36.467 years. That will be the average. Let me double check that I'm writing the right values.